Hello, I'm Maureen de Seyssel, and I'll be presenting probing phoneme, language, and speaker information in unsupervised speech representations. So there's been an increasing use of self-supervised learning models in the speech domain lately, and this kind of models have been used for different types of applications. So for pre-training some models, for other downstream applications, for spoken language modeling, for some kind of understanding in a reverse engineering approach of how language acquisition works. And one thing that we know from these models is that they encode phonetic information, and that's why they've been used so much in the domain of language modeling. So that's really the main type of information that we know is present in this kind of models. However, one question we ask here is what other types of information is encoded within such models, and how, if any, do these different types of information interact. In this paper particularly, we look at models based on contrastive predictive coding. So the one thing we need to know here is that the training objective basically in speech is to predict the next audio frame by choosing the correct sample audio frame among an array of negative samples. And so this kind of models have been used in spoken language modeling quite a lot. So there's been one challenge, there's a resource speech challenge, which used them as baselines and show that, and well, they actually were able to get some pretty good results in terms of phonetic discrimination. Then when coupled with other language models, they've been shown also to help learn lexical and syntactic information. And actually, they've also been used up to do some generative spoken language modeling. Here, particularly, we focus on three types of information. So we will focus on phonetic information, gender information, and language information. So as I said, phonetic information is, we know, present in SSL models of speech, and particularly in CPC-based models. Usually, it's been shown by using some phoneme discrimination tasks, and knowing that there is some phonetic information, well, that's essential in any kind of linguistic-based applications. And yeah, here particularly, we'll be using phonetic classes as a proxy instead of directly phonemes. So we'll be looking at whether a phone is a fricative, a plosive, a vowel, etc. So that's one kind of information we're looking at. A second type of information is gender. So we use it as a proxy for speaker information. And actually, there's been some previous work which suggested that gender information is present in CPC models. And it's good to know whether and why this information is present, because it can be potentially harmful in language modeling applications, and we might actually need to remove it or to normalize it. We do not necessarily care about who the speaker is, and we would actually rather have some more linguistic-based information. Finally, language is something that has not been that much looked into, but it can be useful in specific applications, especially when you have some multilingual training. So for example, for speech-to-speech translation. What we know is that models based on CPC in speech trained on monolingual data do transfer well to other languages. However, we do not really have any information as to whether and how is the language information present both in monolingual and bilingual models of speech, and how it's encoded. Okay, so as I said, our main question is to understand how is phonetic class, gender, and language information encoded within CPC-based SSL speech representations, and we want to understand how these different types of information interact. What do we expect? Well, we expect that models will display some phonetic information, and that they will also, well, that they also do encode gender information. However, we do not really know how and whether is language information encoded, and specifically if it's the same for monolingual and bilingual models. So we'll be also looking at bilingual models. And finally, we want to ask the question, go a bit further, and in terms of bilingual or multilingual training, is there an effect of having different types of information, if any, on some downstream phonetic tasks? So that's for our main research questions. So for the models, we trained 2 monolingual models and 1 bilingual model. So trained on English, on French, and then on the mix of English and French. The models are trained on 3,200 hours and using a CPC architecture. And we're actually also training, well, we're actually also cluster at the discretization step, clustering our outputs for some of our analysis, but I'll be talking about this later in the presentation. So as for our evaluation, we created an evaluation set generated from speech from common voice, so that's red speech. This evaluation set contains 20 hours of speech, balanced in terms of gender, speakers, and language. We then aligned the phone transcription that we have to the speech in the audio, and then now we can actually have for a single phone from the evaluation set, we are able to retrieve its audio alignment, its gender label, its language label, and its phone class label. And obviously, once the models are trained, we are able to retrieve its representations. One more thing I want to point out here is that all of the analysis we are carrying out are done on the last hidden layer of the models. Okay, so we carried out quite different analysis, qualitative and quantitative. I'll start with this one, which is a qualitative analysis. What we did is that we looked at every single phone from our evaluation set. We did some min pooling over all the frames from a single phone. And then we looked at what kind of information was encoded by using some TSNE to visualize the data. And then we colored this TSNE in terms of phonetic class, gender, and language. So if you look at this graph here, the three different columns correspond to the different models. So the two first ones are the monolingual models, and the last one is the bilingual one. And so if you look at the first row here, what we do is that we look at phone class. And what we can see is that phone class seems to be actually quite well separated. So we can say that there is some information, phonetic information encoded with the model. And that's the case for the monolinguals and for the bilingual models. And actually what we also see is some kind of sonority gradient indicating that this information is also encoded. It's the same for gender. So you can see that there is a clear separation between males and females. And that's the case both for the monolinguals and for the bilingual models. So indicating once again that gender information is well encoded within all of our models. Finally, regarding language, which is what we were less certain about. Well, if you look at the monolingual models, it looks like there is no clear separation of languages. So the models does not seem to encode, at least at first sight here, any language information. However, the information seems to be well encoded within the bilingual models. So it means that the model is able to separate phones based on whether the phone is English or French when the model was trained on both languages. Okay, so now we want to see whether this, what we see here, holds when we do some quantitative analysis. And so what we did is that we used logistic regressions as probes so that we could analyze actually our speech representations. And so we used the evaluation set to test and train some logistic regressions over our three different categories. And so what we see is that here in the table, you do see the classification error scores. We do get some pretty good error scores in terms of phone class and in terms of gender for all three of our models. For the language model, we get some really good scores in terms for the bilingual model, as expected from the previous visualization. However, what's a bit less expected is that we still do get some relatively good scores, at least much below the chance baseline for the monolingual models, suggesting that maybe there is some language information which is encoded even within the monolingual models. We actually ran some more analysis looking at the different dimensions to actually test the hypothesis that the information encoded, the language information encoded within the monolingual models was actually much more scattered around quite a lot of dimensions. And that's actually what we found out. So if you diminish the number of dimensions you're looking at and only look at the most important ones, then there is not much of this language information allowing to do this logistic regression properly here. Actually, what we did then is that we looked at the discrete outputs, the outputs of k-means. So why do we do that? Well, actually, a lot of these models, as I said, the CPC-based models of speech are then actually, well, you usually apply some quantization step to then be able to train a language model. And that's how you use it for example, spoken language modeling. And so that's one new type of representation that a lot of people look into, and that's why we also wanted to look at these discrete representations. So we trained a k-means algorithm with varying numbers of target clusters. And then we did the same kind of quantitative analysis by doing some mean pooling over the 100 representations for each of our extracted phones. And so we do have the results here, which I encourage you to look at if you're interested in the paper. But to make it brief, basically what we saw is that the patterns that we saw previously do hold well, between the monolingual and the bilingual data for phone class and gender. So we do see the same thing. It seems that there is no proper difference in the monolingual models and the bilingual models. They're all as good as to encode phone class and gender information. The language scores, however, well, they're still good for the bilingual models. However, they're much closer to chance for the bilingual models. This is not that surprising, as well, when you do this discretization step, you only keep the most important information. Well, basically, only the most important information is used to do this kind of clustering. So it's just one more hint that language information is not that present in monolingual models. Finally, I want to point out that there is no effect of number of clusters on the phone class and language categories. However, it seems that the more clusters lead to better gender classifications in all models. Finally, we wanted to compare monolingual and bilingual models on some downstream tasks, and specifically on the phone discrimination downstream tasks, rather than doing the probing analysis that we did before. And that's to ask the question if there is a cost to multilingual training on these types of downstream tasks. So of course, what we used is an unsupervised evaluation task, and we used the phone ABX task, which is used to see whether the model is able to discriminate between phonemes. And we tested each model in an evaluation set, which was the same as the language it was trained on, if it makes sense. So we tested the English model on English, French model on French, and the bilingual model on a mix of English plus French. And once again, I won't go too much into the, well, I won't go into details into the results here, but what we can see is that all of our models, so the monolingual ones and the bilingual ones, have a pretty good scores, so quite low error scores on the CPC representations, as expected. And there's not that much difference between the bilingual and the monolingual model. So here it looks like there is no proper cost to having trained the model on bilingual data rather than on monolingual one. However, when you do the evaluation on the output of k-means, so on the discrete units, it is a much different patterns where you can actually see that the scores on k-means are much higher for the bilingual model than for the monolingual models. So here what it indicates is that there seems to be actually some cost to bilingual training once the output is discretized. And actually adding more cluster does not help reduce this difference, although you might just think that by doubling the amount of target clusters, we might just get all of the phonemes from both languages, but that doesn't seem to be the case. There doesn't seem to be much difference when you augment the number of clusters. So that's one thing that's actually really important and really interesting to know, is that this kind of bilingual training can be harmful for some downstream evaluation. And that's not something that had been found so far, but that's the case only once the input is discretized. So if you just stick to the representations from the CPC models directly, well, there is no proper difference. Okay, so to conclude, as we expected, both phonetic and speaker, well, at least gender informations, are present in CPC speech representations. And this information is also still present once we turn the continuous representations into discrete units. What we also know is that bilingual models do encode language information, which is good to know. And actually, this information seems to be disentangled from other information. Some of this information might be present in monolingual models, but this is highly scattered or across different dimensions. Finally, one thing that we saw is that there seems to be no impact of having additional language information on other types of information. So the bilingual model has this kind of additional language information, but still has really good information encoded for gender or language. It does not hinder the encoding of these other types of information. And finally, we saw that there is a potential cost of multilingual training, or at least here bilingual training on some downstream tasks. And so there are a lot of lines of research that could be done, but I just want to point out a few different aspects. So we want to look whether this generalizes in other architectures, whether you have any effect or if it generalizes to other languages. And finally, if there's an effect of training size on the language information present on in bilingual training. Okay, thank you very much. And let me know if you have any questions.